Alright, so in this next lesson we're talking about solving equations with logarithmic functions. So, now again, when you see those logs, most calculators assume that they are in base 10. So if you see something like this, like log 27, you need to remember that that's base 10. Alright, and you can put that right in your calculator, no problem, log 27, and you can get a decimal. But the problem is, how do you enter something like log base 2 of 8 in your calculator? In order to do that, you have to break that down using the change of base formula. So the change of base formula tells us that if the log is in anything besides 10, log base b, this is equal to the log of x divided by the log of b. And I like to think of that as like the x is kind of on top here, so it goes right on top, and the b is on bottom, it goes right on bottom. So you can put log x in log b, and that way when you put it in your calculator you can get an answer. So how do you enter this? By entering log 8 divided by log 2. Now when you guys are using your TI Inspires, they do not just assume it's in base 10, you have to put that 10 in. So like here, when you get ready to do log base 7 of 56, you need to enter in your calculators log base 10 56 over log base 10 of 7. So on the TI Inspires you need to actually type in that 10. Alright, and your calculators will now be in test mode so that we can all do it just like you'll have to be able to do it on the test. Alright, and when you put that in your calculator, you're going to get the answer, and it's a decimal, 2.07. So, when you're solving these logarithmic functions, you need to watch out for negatives and zeros. You cannot have a negative or a zero in the log or in the base. And if you remember from the first lesson how the log is just positive, okay, it never gets over here to, it never crosses to negative numbers, and it never gets to 0. So if you have something like this, log base 3 of negative 8, there is no solution for that. The answer to this does not exist. No solution. Or the base, it cannot be negative. Log negative 3 of 8, again, no solution. There's no answer. You can log base 3 of 0, you can't have 0, it never gets to 0, there's no solution. And you cannot have a 0 base either, log base 0, that never happens. So watch out for zeros and negatives for inside the logs, you can't have them. Okay, now when we're solving equations, you actually already know what you need to know to be able to solve these logarithmic equations. You're just going to use the previously learned information about the properties of logs and how to expand them and condense them. Okay, so in general, what you're trying to do is just condense the logs. You're going to have to rewrite the log as an exponential, or maybe rewrite the exponential as a log, and then you can just solve. Alright, so let's look at some examples of solving some equations. Alright, so in this first example I have log of 3x minus 2 equals 3. Okay, I'm going to take this and I'd like to rewrite that as an exponential. The first thing you need to notice is, although it does not have a base down here, we can assume that it's in base 10. Now that we know it's in base 10, we can rewrite the log as an exponential. So my base is the base, and I'm raising that to power of 3 equals the number inside here. Okay, so how did I do that? I followed the rewriting laws that we learned on the first day with rewriting exponents as logs. Now it's easy to solve. 10 cubed is 1,000. Add 2 to the other side, and 1,002 divided by 3 gives us 334. Okay, and sometimes we can solve equations by taking the exponential and rewriting it as a log. So let's see, as a logarithm, what would this be? We're going to have log to the same base of 10 of 9 equals 2x. when we get ready to put this in our calculator, we're going to use our change of base formula to help us solve. So this is log of 9 over log of 10. Then to get the answer, we can just multiply by both sides to get the 2 to cancel out. Either dividing by 2 or multiplying by 1/2. I'm going to multiply by 1/2 so that the 1/2 and 2 will cancel. So when I divide by 1/2, if you can see this, the 1/2, the 2 goes into the denominator. So now I have log 9 over 2 log 10. And I can put that directly in my calculator and get an answer. 0.47712. Okay. In this last example, before I solve, I need to condense the logs into one piece. So I need to condense the logarithms here. I have a plus in between. Well, plus when I'm condensing becomes multiplication. So I'm going to multiply the two things, the two different log parts together. So now I'm going to combine this one log, and I've multiplied them together. Now, after I've multiplied, let's see. I need to rewrite this log as an exponential in order to get rid of the log. So, let's see. This is base 10. I'm going to have 10 to the power of 2 equals x plus 21. 10 squared is 100. Distribute the x. Oh, and looks like we've got ourselves a quadratic equation with an x squared in it. Alright, so we're going to have to actually factorize this one, doing our box factoring. First, make it equal to 0. And now I have to factor this into pieces. So let's come to the side and do our box factoring. Just do it to the side somewhere and figure out what that would factor into. So it looks like this factors into x plus 25 and x minus 4. Okay, so setting each part equal to 0, I get x equals negative 25 and x equals positive 4. Okay, guys, but only one of these is actually the right answer. X cannot be negative 25 because we cannot have log of a negative number. So, the only answer here is that x equals 4.